Wireless LAN Professionals Podcast, episode 174.
But then there's a second, more fundamental problem, which sort of is why you probably shouldn't expect your network vendor to be able to solve this problem, which is that this is inherently a multi-vendor problem.
Wireless LAN Professionals is a place to educate, inform, encourage, and entertain those involved in wireless LANs. This Wireless LAN Professionals podcast is an audio manifestation of these goals. Our host is a wireless LAN veteran, consultant, designer, and teacher, Keith Parsons. And now, the podcast for wireless LAN professionals by wireless LAN professionals.
Welcome back. This is Keith Parsons with Wireless LAN Professionals Podcast, and today I have Anand Srinivas. Did I even get close on that last name?
It was pretty good, Keith. Yep.
Oh, okay. From Nyansa, and we've been talking to people from Nyansa for a long time, especially in the wireless LAN community. A couple of years ago at one of the WOPCs, you had a standing room only session, which was pretty good as you were launching.
Yep.
What we want to talk about today is a statement you'd made of why analytics is no longer a nice to have for wireless professionals. And that's kind of a bold statement, and I like bold statements. It's a good way to start out. So let's see if we can spend our time today talking about and getting some supporting information about why you think that analytics is not just a nice to have, but obviously the opposite of that is a must have.
Yeah, absolutely. And thanks for having me, Keith, on this podcast. So just, at the net of it, it's all about data. Right? When the problem is relatively simple, or there's not that much data, or there's not that many, as we call them, dimensions or like complexity in the problem, you don't really need analytics. You can kind of just look at the data yourself manually, and you can kind of get to different kind of conclusions. And, what I would say is that in the wired world, right, rewind maybe 15 years ago, before wireless, in an enterprise environment where, you'd have devices that people would give you, or that the IT department would give you, like a laptop that they would give you. You would take that laptop, plug it into an Ethernet jack, and then that would connect to a switch, and then you might access an application which was on premise, like SharePoint or something like that. In that kind of an environment, when you think about what could go wrong in that kind of environment, there were very few things that could really go wrong. If there was a speed problem, okay, I need to add more ports and more speeds and feeds on my switches or routers, right? Maybe it was an application problem. Okay, well, it's an on-premise application. I can go after that. And really, those were kind of your two types of problems that would happen. But I think, fast forward to today, when you think about sort of what an enterprise network looks like now, you sort of have a complete heterogeneous device environment. You have BYOD on the one hand, where people expect to be able to use any of their devices and access enterprise applications. So whether that's their iPhone, Android phone, tablet, laptop, whatever it is. And then, furthermore, you have IoT devices. So in healthcare environments, you have infusion pumps that connect to the network. You have X-ray machines. You have all sorts of different kinds of IoT devices that are connected, smart lights and so on. And those need to work as well. And so your device landscape has kind of gone has become very heterogeneous. And so now you have an issue of, can I even trust the device in terms of how it's working? Next, you have wireless, which brings a whole different type of complexity than, your switched network, where it's really just about speeds and feeds. But for wireless, it's about signal strength, it's about interference, it's about layer 2 retransmissions, it's about location and building material and whatever else, access point model, all of that kind of stuff, protocol and so on, which adds complexity. There's network services that sort of wireless, devices rely on much more so than wired devices, like Radius, for instance, or .1x, and even DNS and DHCP is has sort of a different level of complexity with wireless. And then you still have your WAN network, and now you have applications that could be cloud applications, they could be unified communication and so on. And so now when you think about, okay, what could go wrong in this situation, you have many, many different dimensions that you'd have to look at and you'd have to think about. And so when you think about going back to analytics and why it's a must-have as opposed to a nice-to-have, you just have a lot more data and you have a lot more things that could go wrong. And when that's happening, for somebody to manually look through all of that data, like look at data from your wireless controller, look at data from your applications, look at log data from your servers, look at data from packet data and take PCAPs and look at that. All of that, to do that manually and continuously and try and figure out what's going on is just not practical. So you need a machine or some kind of analytics to at least do the first pass of looking through all of that data, correlating it all, analyzing it, running things like machine learning and things like that to sort of get insights and baselines and predict and recommend actions that you can take. And then sort of you can kind of come in and add context on top of that. But that's sort of a must-have because of just the volume of data and the complexity.
But isn't that something that our wireless LAN vendors are touting that they have built in their controllers? I mean, it's not an unknown problem. The problem's been there for a while. And one of the things you missed in your list was all of the wired things are still there. We still have all those problems. They didn't go away when we added wireless. We just added more.
Yeah.
And so the switch router manufacturers and those who support those have had analytics, front ends on theirs. But then the controllers are saying, yeah, we have it as well. So why would we need I'm just playing devil's advocate.
No, 100%. No.
Why would we need an overlay to be babysitting this in addition to the controllers and our route switch fabric that we already have?
Yeah, 100%. It's totally a fair point. I think there are two big things. The first thing is that the typical vendors are, they sell hardware, right? And they sell, hardware, and they sell, software that obviously goes into their hardware. But basically, the software is sort of a way to make their hardware work and sort of differentiate their hardware. It's not necessarily meant to sort of do big, your software on your wireless LAN controller, as an example, isn't meant to sort of do big data machine learning on not only data from your wireless LAN controller, but data from your switches, your servers, your routers, et cetera. Pull in all of that data from everywhere else and sort of run these kind of algorithms, right? So even the traditional vendors, they're not sort of talking about it as doing it as part of their existing hardware. They're also trying to tout, okay, now we have these software solutions that sort of fit as an overlay that can collect this data and sort of do this kind of, solve these kind of issues. But then there's a second, more fundamental problem, which drives, which sort of is why you probably shouldn't expect your network vendor to be able to solve this problem, which is that this is inherently a multi-vendor problem, right? So if you think about wireless, switching, your radius server, DNS server, DHCP server, different applications, different routers, and so on, it's very few environments, and on the application front, it doesn't even make sense, that would just have one single vendor providing all of these things, right? And so you need a system but obviously just because it's multi-vendor doesn't mean the problem disappears. You'd still need to collect data from these multiple vendors solutions, right? And multiple vendor sources. And so what fundamentally happens is that a traditional networking vendor is going to collect data and do analysis to point the problem away from their own hardware, but not necessarily.
Really?
Maybe. But yeah, not necessarily take the data required and do the types of analysis, regardless of the vendor, regardless of the source, to be able to solve the customer problem, which is really getting insight into all of these different client devices and what they're doing on the network and making sure it works all right. So
what you're saying is, just to recap a bit here, the problem is bigger than any one vendor can actually solve right now because they don't own all the pieces.
Exactly.
And even if some big ABC kind of vendor says they have another solution, they'll never have the applications level.
Exactly, because those applications aren't going to be their, that vendor. Right? ABC won't provide all of the different software or all of the different applications that customers need to use in their various environments.
So we agree there's a problem that we don't have visibility into all the pieces of the network. So how does Nyansa go about picking up all of those pieces?
Yeah, so the key thing for us, where we started was we want to be vendor agnostic, right? So we don't care about, the vendor, a particular vendor at any layer of the stack. So we collect data from multiple vendors for wireless controllers. We collect packet data, which is just inherently vendor neutral. We collect data from multiple radius servers, multiple sort of routers, multiple, DNS, DHCP servers, and so on. And so because we're sort of multi-vendor across the stack, and applications as well, but our application support is mainly, that goes back to certain verticals where, in healthcare, as an example, critical applications are things like Citrix or, GE, or, there are other kinds of applications there that Cisco UCM is a critical application in healthcare as well.
Do you also have hooks into things like AWS or something maybe like a Cerner or an Epic, some type of EMR? Do you link into those as well?
So for the EMR type stuff, that's why we do the Citrix integration, because usually they've deployed all of that stuff on top of a Citrix or on top of a VMware. And so we would sort of get the data out of a Citrix, which is the virtual desktop infrastructure, which would then be able to give us insight into what the performance of the EMR applications and so on are. But yeah, so that's an example in healthcare. In manufacturing, there are different types of applications that folks use. In enterprises, there's stuff like Skype for Business and other kinds of applications, Zoom and things like that. And so again, for us, the idea is, okay, where's the problem in any particular vertical? And, we've had traction across different verticals. Healthcare, we've had a lot of traction. We've had a bunch of traction in retail, in general enterprise, in higher education. That's where we've had a ton of attraction, actually. And so just in each of these verticals, the applications are different. But just in general, going back to sort of why we think we can solve it, is we've really taken, sort of an approach very similar to Splunk in some sense, in the sense that we want to be agnostic to the types of data that we get and focus. But unlike Splunk, we're vertically integrated, and we want to solve these particular problems that apply to wireless engineers within organizations. And so to that point, actually, Splunk is a customer of ours, right? Because their stuff, while sort of taking in log data, taking all these data sources and sort of enabling you to search it and enabling you to do certain things on it, doesn't sort of finally solve the specific problems tied to understanding client devices and client behaviors and so on that we do. But really, the way to think about it a little bit is a kind of analog to why Splunk is so popular in sort of IT, in IT departments in terms of collecting data. It's a very similar sort of approach we take, but with one layer on top to sort of actually try and solve problems.
Well, you led into a nice segue here. Mm-hmm. You mentioned client devices. I know you have client agents that run on clients to give you an additional point of view.
Yep.
One of the things we do when we're doing, wireless LAN troubleshooting, we go on site and look and say, what's the client seeing the wireless as versus what's the network throughput? So a very quick way is, you check MCS on the client. If the MCS is good, but the, speed test on that's bad, it's a upstream problem, not a local problem. If the AP is offering 1300, meg and you're only getting 12, then we have a RF problem on the local end. How can your client agents help in that process?
Yeah, so we, to your point, we have a client agent and it works on sort of Android, Mac, and Windows devices. And basically it's doing some of what you said, sort of pulling the MCS and pulling the signal strength and pulling, other like layer 2 retransmits and driver information and things like that off of the device. But the key differentiator for us is that it's sending back this data to our overall platform. So instead of sort of looking at it separately, you can kind of look at it all together and say, okay, in one spot for this client device, I know that the network infrastructure thinks that this is supposed to be its signal strength and thinks that this is supposed to be the access point that it detects and it should be associating with. But according to the client, it has this other measurement. This is what it thinks its MCS is. This is what it sees as the highest strength access points that it's accessing. And then furthermore, our client agent can also do synthetic tests as well. And so ping and download files or do like speed tests and things like that you mentioned. And again, you can correlate that with the throughput of an access point or other factors of what other client devices are doing on the network and so on. And so the client agent, it's an optional thing. Not all our customers sort of deploy client agents because they tend to be quite, you're not always able to deploy client agents on every single client device in your environment. So it's an entirely optional thing. But when customers do deploy like a subset of client agents on a subset of their client devices, they do get a bunch of additional insight that sort of reveals some of the issues that you talked about.
One of the things you mentioned was you think what the controller thinks the AP the client should be on.
Yep.
How do you know from your data collection where the client is?
Yeah. So okay, that's fair, right?
So the client knows which AP he should be on because he knows where he is.
Yep.
Well, he doesn't know in relation. He just knows this is the best I see. How can you correlate that back to know which we think he should have been on this AP instead?
So on the one side, we see the infrastructure perspective, where an AP can tell you, look, I detect this client at this signal to noise ratio, but obviously that's an uplink measurement. So that's at the access point, sort of judging what the noise is there, where the access point is, and what the signal level he received the client at. It's up to the client to say what his signal to noise ratio, where it's located is. And that's kind of what I was getting at in terms of being able to look at both of those values in one spot. And, I think the general assumption in wireless is that it's sort of a symmetric link, that the client sort of sees the same thing as the access point. But in practice, that's definitely not the case.
Not at all. And nor is MCS up and down are totally different.
Yeah. Yeah.
So the idea, I like your idea that you're going to correlate those two pieces of information to say, oh, this was the end result would be wonderful if you could say, this client chose the wrong AP for where he was. Because sometimes they do that.
Yeah, exactly.
A lot of the times.
Exactly.
Well, one of the things I'd like to see in your client agent is from an end user standpoint, I would rather have the client agent tell the customer what the problem is so that when they call support, they don't just say it's Wi-Fi. That they can say, because that's what normally happens. They call in and go, the Wi-Fi is down here. And then you send someone truck roll, they show up and go, Wi-Fi is not down at all.
Yeah.
Your Citrix app just timed out.
Yeah.
Is there a way that you could add to that client that the end user can see the agent and the agent says, from what I saw, this is your problem when you call, say these 7 words.
Yeah.
Put some intelligence in the client app itself, and then the end user can call support and say, it's not this, it's not this, it's not this, but we're getting a DHCP response of 47 seconds.
Yeah. Yeah. It's funny when we talk to customers, they're very wary of other groups, first of all, like the help desk and people like that getting exposed to this kind of data, let alone end users themselves. And so what we find is that
they don't even want to push it to the help desk.
Right, exactly. That's what I was saying, right? Or that's kind of what we've seen. And so, we've had a few customers sort of ask us about, hey, can you make this sort of a self-service thing where it's the client agent or, even the platform itself, end users themselves can sort of log into it. Well, in practice, what we found is that for the most part, people are very wary of that. So it's like, that's why we've kind of built it to focus on the network operations and network engineering and wireless engineering kind of use cases. But it's one of those things that, maybe as customers sort of ease up, or maybe, one of the things that we find is that they want to customize a lot of the data that goes out to other groups and things like that, and like much, much simpler than what we provide to them. And so as we sort of develop those things, I think we'll see more and more of that, but the first step will probably be to the help desk and getting sort of adoption there, which we have in many environments. But in some other environments, they're like, no, you got to dumb this down even more and make it simpler for the help desk. But then once we get there, I think then we can kind of look at end users themselves directly doing it.
Yeah, I would have thought in higher ed markets, they would trust the end customer more. But if they don't even trust their help desk with it, so to get to that, you'd mentioned a little bit about customizing the output. Do you have APIs available that people could take the data from Nyansa's database and pull it over into some other application that they want to run?
Yeah, definitely. So the whole platform supports APIs to pull pretty much anything out. And a bunch of our customers are sort of using it for very interesting sort of use cases. Some of them are sort of like to create dashboards and things like that. But for the most part, what they're using the APIs for is to solve like other kind of business problems that they have. So one of our customers, for instance, is using it to sort of figure out where people are moving around in their large public venue, right? So they pull out sort of location data and historical location data and sort of can figure out and do analytics and tie it back to some of their data on where different users are in the environment. Right. Another customer is sort of, pulling out data to sort of look at like, different kinds of like, what kind of what kind of devices are being used in the environment, what type of applications are being used, where are they being used, and then tying that to other kinds of systems as well. We've sort of seen in some education, like some higher ed customers, where basically they want to figure out what makes students graduate faster. And so data that they can pull out of our platform that relates to that is stuff like, what applications are they using? Are they using the open courseware or the lecture software? Are they spending time at the library and things like that? But then obviously correlate that with data we would never have, like student grades and things like that.
I thought you were going to correlate that with beer consumption.
There you go. Maybe they have that data too, but we haven't tapped into the keg system yet.
So one of the issues of this big data, AI, machine learning kind of grouping is, from a wireless LAN professional standpoint, I'm sitting in, babysitting a controller. One of the things we have to rely on today is, and I'll just use the generic term RRM that's Cisco's specific term, but how the radios take care of themselves.
Yep.
You're getting some extra data that a controller wouldn't have. And I don't want to imply that there's not going to be a human in the loop, but could there be a report that comes from your software that says you should do X, Y, Z?
Yeah, no.
Eventually, I'm hoping, maybe 5 years from now, that's not a you should. It just does it automatically, sees the difference and says, oh, let me adapt, and it fixes itself on the fly by getting enough data back.
Yep.
That feedback loop that AI can give allows us to take a human out of that at some point.
Yeah. So I think, for like an example of like data that we're sort of analyzing that a controller wouldn't necessarily see is end-to-end application performance, as an example, right? So, on an AP by AP basis, where's the best Citrix performance? Where's the worst Citrix performance when it correlates with, wireless, as an example, right? And we can kind of see and correlate that with, well, okay, actually Citrix was bad on this particular access point for these client devices. And the root cause of it was coverage, because the signal to noise ratio that those clients had while they had bad Citrix was low. And so the problem was coverage. And the solution for a coverage problem when you're detecting low signal at the access point is actually to reduce the transmit power of the access point so that clients don't connect from so far away, right? And so that's an example of, okay, well, we get this data, we have sort of this, input to say to RRM or ARM or any, I think it's Channelfly, I guess, for Ruckus or whatever, right? It's to say, you know what, you should reduce transmit power on this particular access point. What we found in practice, again, sort of going back.
But better than just that, it's the feedback that then they changed the transmit power. You see whether or not it had an effect, and there's a feedback loop that says, oh, that didn't work, so next time we're not going to do that.
Right. So that's something we do today in the sense that so where we kind of stop is we make the recommendation today. So we say, you know what, this is what we see in practice, these clients having these kind of problems, and here's a recommendation on where and what you should do to fix it. Whether it's reduce, the max transmit power, or whether it's, it's pick a new channel or whatever it is. This is our recommendation to you, that this is where we see these kind of problems and these are the actions you can take. Where we stop, because of the fact that I think customers in general, this is a different kind of sort of sensitivity than the help desk and the end user side we were talking about earlier. But this sensitivity is more like, I think I still want to add context, to make sure that I'm taking the right actions. I don't know if I trust a third-party system to just all of a sudden sort of like program, what do you call it, my RRM or ARM to sort of take these actions automatically. And so where we stop is sort of we make the recommendation, then the engineer sort of takes that recommendation and decides on their own with context to say, okay, you know what, I am going to make these adjustments to the ARM configuration or the RRM configuration. And then once that they make that, what they can then see in the product is the feedback loop side of it is, did it have an effect or not? And that's probably, again, that it goes back to sort of baselining what normal and what performance looks like, and sort of doing that in a very granular way, on an AP by AP basis, or in a floor, or in a building, or across the whole environment, doing it not just for Wi-Fi RF, but application performance and so on. So then people can, after they've taken an action, can kind of see whether the effect was good or bad, or just no effect whatsoever, and sort of decide what they're going to do after that.
Your recommendation was do X, Y, Z. How do you then see that trigger was actually done? That you have that trigger event that says, oh, RM just lowered the transmit power.
We look at the configuration on the wireless LAN controller. We take snapshots of it, and anytime we see sort of a difference in the configuration, we automatically annotate any kind of configuration change.
Is there a report that follows up that says, we saw this annotation that said this happened. We gave you a recommendation because XYZ was a problem. You made the change. And is there a follow-up report that says, and it worked?
So it's not that curated yet, but you could generate a report on, okay, these are the annotations that occurred, and these were the effects of those annotations. And then, it's sort of up to you to follow up. But it's a good point, actually, to have a more curated version of it, which says, hey, we detected this automatically, and we noticed that you tried to do this, and actually our recommendation would have been to do this instead. Or
and your big data engine needs that feedback to know whether or not it was making good recommendations.
True. Yeah, definitely. And yeah, I mean that, but the first step of it, of course, is to even just measure everything the right way and sort of have the ability to do it. But you're absolutely right, which is that, the whole promise of all of this is that you can kind of have this sort of feedback loop sort of work. But then, the thing that we've found that's really, really critical is that engineers need to add context to it. The notion that everything is just going to be automated, this sort of like Skynet type automation or whatever for everything, I think is, is not the reality of 2009.
Yeah, I don't know if anybody wants that.
Yeah.
But part of your allure is you're collecting all this wonderful data that we can't get as individual. We just don't have the bandwidth to see that. Yeah. And nor can we have the time to look and see all the pieces.
Yeah.
And you give us this nice information, give us a recommendation. But the real value is that your system learns that every time it makes a mistake or it does the right thing, that in the future I learn to trust your recommendations more and more and more.
Yep.
Maybe the human will never be out of the loop, but I might start trusting your answers because I see the results. The other, and something I love about what you've done from the very beginning, is allow me to say, I'm thinking about moving to 8.4.2. Did it help my neighbors before I do it myself?
Yeah, definitely.
Because there's some pretty big changes there, and lately code stability hasn't been the best. And I don't want to be I don't mind being on bleeding edge, but that cutting edge, cutting good. But when I start to bleed and then, there's just blood everywhere, that's not a good thing. We'll let some other people do that.
Yep. No, definitely. And that's why I think it's, I think we talked about it at actually the first WLPC, where somebody asked about, this notion of network friending, this idea of, hey, I want to be able to see some of the changes and some of the baseline data, but obviously not any personal data of some of my cohorts. So similar universities with, similar wireless, or at least similar sized universities and things like that, where they can say, you know what, I'm, University X, and my friend University Y, I see that they went to this code version, and I see that this is what happened when they did it. And so, you know what, and, that's actually true of universities, A, B, C, and D as well. And so, maybe I don't want to do that.
Or even little things, standard best practices. Do we turn off 2.4? What channels do we use? Are we 40 or 80 megahertz? And there's a lot of data that you're collecting that could lead people to make better decisions where they are.
Yep.
Some of the reports that GT has shared of, this is what 85% of the people have been doing, and the top 10% do this, and the bottom 10% do something different. Which one would you rather be in?
Yeah. No, for sure. That's again, like it, going back to the very first question about analytics, now you're getting into, okay, we talked about the impracticality of collecting data just in your own environment, but now there's data from other similar environments that also can give you a lot of valuable insight into what's going on in your environment. And that's just data now you have no chance of collecting, right? Or like a person sort of manually being able to collect that data. And so again, analytics sort of comes into play there, which is that there's just so much data, not just from your environment, but even other similar environments. And, internally we kind of call that cloud sourcing, right? This notion of, collecting data from multiple environments and sort of getting insights from all of it combined. But again, it's something that, if you're going to try and do that manually, it's very difficult.
Well, one of the things I like is the community involvement. As a community, we there's a bunch of best practices, but best practices are kind of foofy. I mean, they're not hard. It's, I liken a lot of times when I'm talking about wireless, wired to wireless. Mm-hmm. When you have a Cat 6 cable, there is a very specific near side crosstalk number, and you can hook up a meter to it and measure it. Yes, I'm at it or not.
Yeah.
There's no cat Wi-Fi.
Right.
And so we're all kind of floating around there trying. And one of the things we run into as engineers is we go to management saying, we recommend this. And they're like, well, is it going to be good or bad? Yeah. Why did you recommend that? The manufacturer says, well, a simple one, they always say manufacturers recommend 80 megahertz because manufacturers ship 80 megahertz as default. And those are two separate things.
Yeah.
And so when your management tells you, well, why are we doing this? It's really nice to be able to go and say, well, the top 10% of all of the universities our size are doing this. Yep. And we're doing what the bottom 5% are doing. So how about if we make a change? So giving that supporting information is really helpful as well.
No, for sure. And what we've seen in practice there is that the other side is the bow on it, which is that, hey, I made this change because of that, initial insight. And here's the proof that it actually did make a difference, right? Rather than relying on surveys and anecdotal data, which is kind of noisy, right? If you're just relying on people saying, yeah, it got better or it got worse. Because I think people are more likely to say it's really bad than really it got better. But in any event, you're able to sort of see the baseline get better or get worse, and you're able to prove it. So you start off with, yeah, we're making this change because, we see this data about other people. And then at the end of it, it's, yeah, we made the change and it actually had the effect that we wanted, and here's the proof of that.
Proof is always good. Data upstream to management is always a useful piece. You need to have like a special report. This is called the CYA report. The little button for if management doesn't see it, just engineers, the little button that says here. Give me my supporting document so I can keep my job next month.
That's awesome. I might ping you offline, Keith, and ask you what we should put in the CYA report.
So if someone is listening to this podcast and they go, I think I would like that kind of solution in my environment? What does it take if I'm an enterprise and I'd like to play with Nyansa?
Yeah, so there's two options. One option, which is the simplest thing, is actually to go to our website, www.nyansa.com, and you can actually directly access the product as it's working on sort of an anonymized network environment. And so you can kind of see in practice all the data sort of anonymous or whatever it is, but what data actually looks like, in the platform, and you can kind of play around with what kind of data you can expect to see in that environment. So that's something you can do off the website itself, sort of get access to a real environment. If you want to see the data as it pertains to your specific environment, that's also pretty easy. Just reach out to us, either again from the website, which is probably the best way, or info@nyansa.com. And ask us for a POC. And so, for that, we sort of the simplest way is we have a piece of software we call the crawler that most of our customers, we just kind of put it on a server and we ship you the server. And that server's job is to collect data. But then once it collects data, the rest of it sort of, all the analysis or whatever it is, sort of just happens automatically. So you can kind of, we send you a server and you can sort of trial it or POC it with your own data on our public cloud solution, which we host on AWS. But of course, we also offer a private cloud solution version of it as well. So if you don't want data to leave your premise, then, we can host in your data center and your data sort of stays local. But it's very simple. So we give you a crawler. It's less than an hour to set up. And then you start seeing insights right away, basically in your environment. But the first step, the easiest thing, which is much, you get up and running within minutes, is to just go to the website and then sign up for a demo account, and you'll get a view of the product there itself.
And you can play with. And is that like all of your customers together anonymized, or is it filtered at some level?
It's
as in, is it enterprise versus education versus hospitals?
Yeah. So we have what do you call it? I believe the one that we put up is sort of a representative enterprise. That's the demo account. That's on there now. Going forward, we will put like multiple demo accounts, sort of like a demo account that's a representative university, a representative hospital, a representative enterprise. But the one we've got up there right now is a representative enterprise.
Okay, and Nyansa also has, last year was your first conference, and you have another conference coming up. When's that next conference?
Yeah, definitely. It's going to be, I should know this date. This is really bad on my part, but it's basically, I believe it's around middle of this year.
Well, I think I can help you with that because I have it on my calendar. So let me just flip up the calendar. Sorry, I asked you a question. I thought it was like really obvious. It's May 30th and 31st.
All right.
So it's the end, the Thursday, Friday after Memorial Day.
That conference, we're thinking of doing some pretty exciting stuff this year in terms of including things like API workshops. And sort of like, using the API for all sorts of interesting things. And of course, just a lot of the types of talks from customers about, use cases they have and, things that they see. And, it's not even all related to Voyance or Nyansa necessarily. It's just general things that they think are sort of important to the industry and interesting to folks. So
yeah, I attended the conference last year and was actually I learned a lot and I was surprised of how obviously it was Nyansa based.
Yeah,
but there was a lot of sessions that were just good technical sessions that really didn't have that much to do with the product. So kudos to your team for pulling that off.
Yeah, no, for sure.
Well, any final last statements you'd like to share?
No, I think we've covered a lot of it, but no, definitely. I think one of the key aspects of sort of realizing the value of analytics and realizing the value of a platform like ours is sort of really seeing it in action and seeing it with your own data. right? And so really, the conversation we just had around, okay, well, how do I see this in my environment with my own data is, let us know that you want to do that. And getting a POC up and running is sort of a very trivial thing, right? Once we figure out that that's the right next step, and then you'll get to see insights sort of tied to your environment. And as part of that proof of concept, which usually lasts around 3 to 4 weeks, we'll sort of work pretty closely with you to sort of make sure that you're getting the right understanding and the right value out of the platform. And I think, folks will find a lot of value there.
Well, great. Well, I appreciate your time today and look forward to seeing you in the future.
Awesome. Thanks, Keith.
Thanks.
Yeah, take care.
Thank you for joining us for another episode of the Wireless LAN Professionals Podcast, the podcast for wireless LAN professionals by wireless LAN professionals. Be sure to follow us on Twitter at Wireless LAN Pros for all the latest news and updates, and also connect directly with Keith on Twitter at Keith R. Parsons. Head over to www.wlanpros.com for this episode's show notes, as well as the latest in all things Wi-Fi.